let's talk about alternative reducing agents. The first one that we're going to talk about is using iron. So in an iron vat, we specifically use an iron salt called iron 2 sulfate heptahydrate. And this salt is soluble in water. So what that means is when we dissolve it to water, the salt will go away and it will break up into its constituent ions. So iron 2 plus or ferrous ions, and then the sulfate or SO42- counter ions. Now, the Fe2 plus or the iron 2 ion is what's going to go and do the interesting chemistry. So when we react iron 2 plus with indigo, you're going to have two iron 2 plus ions, each of which will transfer a single electron to an indigo molecule. And we're going to have two Fe3 plus ions left over. So those iron ions have been oxidized, their positive charge gets bigger, whereas our indigo is going to receive two electrons from the iron ions, and then it is going to become the leucoform, which has two negative charges and coming from the two extra electrons. So that's our first type of alternative vat. The next type that we're going to think about is the sugar vat, but specifically using the sugar fructose. So this is a structure of what sucrose looks like. So here I have it written in its 6-part ring form. And what's really interesting about fructose is that it's one of what we call a reducing sugar. So you may think of sugars as being rings because that's how they're commonly represented. But when we have sugars under the right conditions, they can actually have their ring open up and be a chain. And that's what can cause interesting chemistry like reductions to happen. So specifically for that to happen, we need to have base, or we have to have OH- ions floating around. And in an iron vat, we typically use calcium hydroxide or calx. So that OH- is going to go in, it is going to remove a proton from an alcohol. Those electrons from that OH bonds are going to collapse onto the oxygen, and then we are going to end up with an O- on our ring. Now, if you look at this, you're like, Dr. GB, hi, you told me the ring would open. Well, we have to have a little bit of rearrangement to happen first. So that extra lone pair electrons on the oxygen can collapse, and then the bond between the carbon and the oxygen that is in the ring is going to break, and those electrons are going to go to that oxygen that is in the ring and have an O- charge. And so as a result, we have this funky structure here, which is an open sugar. And so we can think of the sugar form as being, the circular form as being locked. And when we break apart the sugar ring, now our sugar is unlocked, and that ketone is what's actually able to facilitate the donation of two electrons to another molecule like indigo.